This morning's topic is combining two main technologies, and that's ArcGIS from Esri and Fabric from Microsoft. So today's presenters, alongside myself kicking it off, we're very happy to have presenters joining us from across the region and from across different companies. We've got Srijith from Microsoft, Sarah joining us from Esri in Seattle, and we've got Edward here in Wellington. So what we wanted to cover off, we're conscious that many people on the call have a variety of different backgrounds and maybe not familiar with either Fabric or ArcGIS. So we'll kick off with some introductions to both of those technologies. And then we'll look at Esri and Microsoft working together, and then specifically looking at the ArcGIS from Microsoft Fabric and the capabilities that brings. We'll show some demonstrations that hopefully illustrate some of these points. And then from Sarah, we'll be very lucky to get a bit of a roadmap in terms of the technology moving forward beyond what's available right now. And we'll finish off with some Q&A at the end. So in terms of Q&A, you should see on your screens to the right-hand side an option to start a discussion, and that's the way we'll take our questions today. Feel free, as we go through, to add your questions into that panel, and we will capture them, and then we'll do our best to answer those at the end of the session. And we'll go to our panel, and we'll also be joined by two other folks joining us from Microsoft to help answer any questions you might have relating to this topic in its widest sense. So please do use this option to add in any questions you have at any time throughout the webinar. So we'll start off with a little bit of a background in terms of what is ArcGIS. I know that many people on this call are very familiar with this technology, but we thought we'd just recap a little bit for those of you who are less familiar with it or are new to it in its entirety. So in an abstract concept, we talk about geography being one of the things that GIS uses. It's the way of viewing a world through the concept of where, location being a key part of almost any data set. It's important that we see this as an interconnected ecosystem, and we use things like GIS to bring those different ecosystems together, combining technology and geography. We can use this to integrate geography and location into our workflows, and as we'll see shortly, into our systems that we use. In terms of how the GIS sees the world, we talk about the concept of layers of data, and those layers of data can represent the built environment, human environment, or the natural environment, or very commonly a combination of all of those together. In terms of how those layers are formed, we can call upon many different formats of data to bring together and combine in those layers, whether that be GIS traditional formats, CAD data, BIM, imagery, and many, many more. And this is the real power of GIS, is bringing these data sets together, combined to make maps and to analyze. We'd like to think of GIS as being a tool that's useful for everyone. Many of you on this call today would be GIS and IT professionals, but some of you might also be data analysts or scientists. And so we'll look at shortly how we can combine GIS with other data analytics tools, in this case, Microsoft Fabric, to open up the power of where, the power of geography for everyone. ArcGIS itself has got some core capabilities: mapping, 3D visualization, imagery, spatial analytics, field operations, and data management. And they're available through a number of ArcGIS products and applications, such as Pro, Enterprise, Online, and then location platform developers. But a really important extension to this is taking that capability, as we've said, and making it available through geo-enabled applications, taking the power of where, taking the layers and those spatial analytics capabilities and making them available through other non-GIS focused applications. So that's a bit of an overview for ArcGIS. What I want to do now is pass across to Srijith from Microsoft and take us through what is Microsoft Fabric.
Thanks, Scott. Hi, everyone. I'm Sridhar. I'm one of the data and AI technical specialists at Microsoft. So Fabric is the next generation data platform from Microsoft. So we call it as the data platform for the era of AI. So before we jump on to Fabric, right? So let's have a quick look at what are the typical challenges that an organization faces and how Fabric aims to solve these challenges for. So in a typical organization, right, an organization who have grown organically over time, there are a variety of data sources like your on-premise, multi-cloud, external, and there are different functional teams like sales, marketing, etc. Right. So often these teams, they do their own things from a data analytics perspective. They'll be having their own tools, systems, and processes, which will result in a lot of like data silos. There won't be a single source of truth. You'll end up in having data quality issues like duplicates, missing data, and all this disparate tool makes collaboration really harder. So the end result is it's very hard to get timely access to the information that everyone can trust. And also a complex data state, right? It actually limits interoperability and not an ideal place to start your AI innovation. So what's the solution? So as you all know, the solution is basically to build a data platform which can work as a single source of truth where everyone can trust the data and use it to gain insights from here. But it's very difficult to say. It's very easy to say, but rather than implementing it. Scott, if you can go to the next slide, please. And the reason is this. So if you can see here, right? So our analytics landscape is completely complex and fragmented. So what you see in the screen are literally the different collection of products in the current data analytics landscape. There are literally hundreds, if not thousands of products in the market. There are separate products for data ingestion, data analytics, and visualization. So typically, customers have to purchase and pay for these tools separately. They have to spend time and money to build these integrations to make it all work. And also, customers have to bear the cost of moving data from one system to another, like from your data warehouse to the visualization layer. And all these disparate tools, right, they create new set of data silos. So basically, in solving the data silos issues we discussed originally, we end up in creating new set of data silos. And some of these tools, they store data in their own proprietary format, creating vendor lock-ins. So for example, your data warehouse might store data in their own proprietary format. And if you want to run machine learning or BI on top of it, you need to convert that into a different format. And then customers have to bear the cost of converting that data format. And the list goes on. So these are typically the number of challenges that the customers have to deal with in building the data platform. So let's go to next slide, please. So introducing Fabric, so which is industry's first SaaS data platform built for multi-cloud data estate. So I often like to compare Fabric with Microsoft Office, which is the suite of productivity tools like your Word, PowerPoint, Excel, etc. Right? So all of these tools are actually optimized for a particular task, like building a spreadsheet or writing a document, etc. Right? But all these applications in this Office suite share common elements in terms of user experience, like how do you do the spell check, copy, etc. Right? And they all share the same foundational layer in terms of governing your Office applications, like how you store and collaborate on files. So think of Microsoft Fabric in the same way. It's a suite of analytics tools. So we have 7 different experiences within Fabric. They all come integrated with each other. So whether it's all about integrating your data, building a data warehouse, or unleashing your data in Power BI. So each of these tools, right, they share common elements in terms of how to connect the data, how to manage your artifacts in your workspaces, or how do you do your CI/CD in terms of moving your artifacts from dev to test to production. So when you talk about 7 different experiences, right? So we have Data Factory for your ETL tools, which has got around 200 plus connectors where you can connect to the data sources, bring the data, do the transformation and load it into a target state. Then you have your data engineering experience where you can actually build your ETL transformations using a notebook-based approach. So you can actually use PySpark, Scala, or SQL to do your transformations using a notebook-based approach. And then you have your Lakehouse for a data warehouse for your data warehousing needs. And then there is a data science experience where you can actually build your machine learning or data science experience using the data science component within Fabric. And then there's a real-time intelligence component which enables you to run your analytics on top of big data in near real time at scale. And of course, Power BI is part of Fabric. And then there is another experience called Data Activator, which enables you to take actions on top of your data, changes on your data points. So all these experiences are actually part of Fabric, and they all share the common artifacts like one lake. So we basically store data in one lake, and all of these experiences have got Copilot enabled, which is like we have basically infused AI in the form of Copilots across all different experiences, and they are all governed using Purview. So when we talk about these experiences, right, they combine the best of Power BI, Synapse Analytics, and Data Factory, and all this experience to create a single unified SaaS platform with all of these workloads, each purpose-built for specific personas and specific tasks. So next slide, please, Scott. So let's quickly go through some of the key features of this platform. So as I mentioned before, it's a complete analytics platform. So Fabric actually provides a single unified experience for all of your personas in your organization, like your business users, data analysts, engineers, data scientists. They all collaborate via this single unified common platform. And Fabric is a SaaS platform as opposed to some of the PaaS offerings. So in this PaaS platform, all these different experiences are built into the same unified platform. They all come integrated with each other, ready for you to use. So it's a no-code, low-code approach towards data analytics. And Fabric also comes with Azure Enterprise Grade Security and Microsoft Purview built in, where you get data governance out of the box. So which means you can actually get data classifications, lineage, and labeling without having to do a lot of configurations in there. And Fabric is also a lake-centric approach. So in Fabric, all of your data is stored in an open source Delta Parquet format in one lake. And there's only one copy of data. What that means is you don't have to move data across different formats for different experience to use. So like your data factory can actually write data into the one lake and into the Delta Parquet format in one lake, and then your lake host, data warehouse, and even Power BI can also consume the same copy of data, which is sitting in your one lake. And all these experiences, including Power BI, are natively configured to work with the Delta Parquet format, and there are no proprietary logins anywhere in the platform. And Fabric empowers our business users with its deep integration with Microsoft Teams and Office experience. So imagine having your Power BI reports available to you in Teams. It becomes a live dashboard, including in your Power BI slides as well. So it has got a deep integration with its Office suite. And last but not least, it's actually AI powered. So it comes with Copilot across all different experiences within Fabric. So you'll be able to build your data pipelines, machine learning models, or Power BI reports using natural language without having to do a lot of coding in there. You should be able to you should be able to generate summary of your Power BI report and also use the Fabric data agents to interact with your data using natural languages. And the best part is you should be able to build your ChatGPT sort of model on top of your data using these Fabric data agents. So with this, I will pass on to Sarah.
Thanks very much. So I'm going to talk a bit about the Esri and Microsoft relationship and the integrations that we have specifically in the Fabric environment that build off of what you've just seen. So in terms of history, Esri and Microsoft have a long history of collaboration to enable platforms where our joint customers are working. And I think this started back probably in the late 80s, 1980s, with the initial release of PC ArcInfo. And it continues today, really driving innovation in geospatial technology and in enterprise solutions. So over the years, this collaboration has evolved significantly, leveraging advancements in location intelligence, in cloud computing, and in data analytics. So I want to give a little overview of kind of our collaboration centering around this ArcGIS for Microsoft set of offerings, just as a bit of context to start with. So the ArcGIS for Microsoft components deliver these mapping experiences to everybody in an organization through direct integrations with Microsoft 365, with Power Platform, and now with Microsoft Fabric. For custom applications, there's also a developer store using the .NET SDK and a secure place to deploy core technologies on Azure infrastructure. So as a whole, this integrates with Microsoft productivity applications, intelligence services, and configurable app and process builders, allowing users to interact with spatial information and to better understand patterns, relationships, trends, all within the apps that they know and trust. And so what I'm going to do today is really just dig in on the Microsoft Fabric part of our integration story. So this is a continuation of our support for users across Microsoft's platforms. And what we're trying to do is really help people unlock the where in their data through spatial visualization, analytics, and insight, and exposing all of these using ArcGIS and delivering through the seamless experiences within the Microsoft Fabric workloads that we just learned about. So within Fabric, users can work with data, including data they may not think of as spatial data, to unlock new insights that they can really only uncover by leveraging these spatial relationships and asking spatial questions. ArcGIS for Fabric is really enabling these capabilities, really for all kinds of knowledge workers, the business intelligence analysts, the data scientists, the data engineers, and more. Pretty much anybody who has access to a spatial data set and a question they want to ask about that spatial data set. We're trying to light this up across the Fabric workloads to really enable every user, wherever they are, to be able to access their data that they have in their organization and to use it effectively. So let's dig into these integrations and look at how they get exposed through these core Fabric workloads that we discussed earlier in the webinar. So the first is the Power BI applications. So we have ArcGIS for Power BI, which is enabled through this workload within the Fabric ecosystem. And that's something that's available today. And this provides location insight through Power BI dashboards and reporting. And what that looks like is that ArcGIS for Power BI really adds a new layer of depth to analysis within existing or new Power BI reports. It enables users to leverage location to explore whatever the key context is in their data. So sales, customers, or other key enterprise data sets that provide this spatial context that they need to explore. Throughout reporting workflows, ArcGIS for Power BI lets you read spatial information from a data set or convert location information into features on a map by geocoding it or matching it to well-known geography. So this means that you can spatially enable data from your Fabric OneLake and do it within the Power BI experience. Within Power BI, the ArcGIS visual that you can add is fully interactive with other report components. So it could be used as a filter or be filtered as users interrogate the report. It can also be extended with other layers to provide additional context. So for instance, being able to incorporate demographics or areas of interest. And those can be pulled from things like ArcGIS Online or Enterprise as well. So this is enabling data citizens and report creators to configure reports that provide new forms of insight to better support their business decisions. The second integration point that I wanted to talk about is that we're delivering ArcGIS GeoAnalytics through Fabric's data engineering and data science workloads. And so this is bringing an authoritative library of geospatial analysis functions that you can leverage using Spark, which is a distributed computing framework, and you can apply it to your big data or your big analytics problems. Using GeoAnalytics, we're able to allow users to uncover patterns and trends in very large data sets and to bring location insight into predictive analysis workflows. And this is available in public preview today. And I'll talk about it in more detail, and we'll provide some demonstrations after we do this initial overview of the integration points. So as noted, GeoAnalytics for Fabric is in a free public preview right now. And through this, we're offering spatial analytics for users of Fabric's data engineering and data science workloads. So this brings our extensive industry-leading spatiotemporal big data analysis capabilities directly into Fabric. Use the Spark-based Synapse notebook. You can automate your data engineering workflows, but you could also enrich non-spatial data to spatially enable it, add in related information based on proximity, do spatial transformations, anything that's really a part of the analytics process that you need to drive using these Spark-based notebooks. And then third, we're working on an end-to-end mapping and visual analytics environment that will go above and beyond the capabilities available today. And what we're doing is creating a brand new focused Fabric experience that'll be presented as a new Fabric workload. And that's going to be able to enable users to map, to visualize, and explore data within OneLake seamlessly alongside data from ArcGIS. This is something that's in active development now and currently planned for later in 2025. So what this looks like is, a full-fledged interactive mapping component that will deliver an immersive experience for integrating enterprise data and for performing spatial exploration to quickly gain insight. So in many ways, this will be similar to the map viewer experience that you likely work with today. You'll be able to dynamically mash up data from OneLake, combine it with data from ArcGIS, and this will allow you to visualize and examine that data together, use maps to provide context for the data, save the maps within Fabric so you can share them with stakeholders. I think of this as just opening up mapping to everybody inside the Fabric environment, and it can drive new questions and new analyses that you're doing with other Fabric workloads. So through this, a variety of mapping and visualization capabilities will be provided to every Fabric user. However, you'll also be able to access an extended experience with more capabilities if you bring an ArcGIS user type as well. So to think about how these integrations fit together, I like to think about it in terms of a medallion architecture and the types of analyses that we might enable across Fabric with data that's really structured with something like a medallion architecture. So if we think about this in this way, we can help organizations enhance the value of their data across the data life cycle. So this really starts with thinking about what we're doing at the bronze level, where we've got raw data that's coming into Fabric through OneLake. It may live in OneLake, it may be mirrored into OneLake, it may be spatial, it may be non-spatial, but we need to do something with that in order to really make it, enhance its value in our organization. So we can look at the silver level of data that's been cleaned and augmented and filtered and transformed and often spatially enabled. And that's using some of the Esri technology to help create valuable information from this raw input data. And the information uses a well-defined structure and schemas that really make it ready for data science teams to use or for use in the interactive mapping integration that we're working on. And finally, we think about users generating these gold level data sets, these business ready aggregates that are meant to be used in BI and other systems. So we're working on really embedding our capabilities into Fabric so you can take advantage of spatial analytics throughout your data workflows. So what I want to do now after that general overview is just give a little bit more detail about the GeoAnalytics for Fabric capabilities and dig into some of those details on the product, its functionality, and how it fits into your Fabric environment to support well-documented, reproducible, automatable spatial analysis at scale. So first thing, this is a Spark native library integrated in the data science and data engineering runtimes, and it's just natively included. So when you're working inside a notebook experience, you can just import the library and start working with it. And using this library, you can apply powerful spatiotemporal and pattern analysis to a range of different workflows. We have more than 180 spatial functions and tools, and they're going to facilitate doing all sorts of things. Spatially enriching customer data based on location, cleaning and analyzing movement data, assessing distributions, performing temporal analysis, finding similar locations, really all of these core things that drive our ability to understand the world around us and to be able to do it at scale because we're taking advantage of Spark's distributed computing framework. We're enabling these workflows by providing the vast majority of spatiotemporal analysis tools that you may be familiar with from other ArcGIS products. So a number of them are listed here, including aggregation, spatiotemporal joins, and pattern analysis, as well as some machine learning tools and movement analysis. In addition to those end-to-end tools, we also include a number of spatial functions, which are the low-level constructors and operators that allow you to really craft exactly the functionality you need if those specialized tools aren't sufficient. So these are all ST-like functions, really just the core, how do you work with spatial data functionality. In general, they've been patterned after PostGIS and follow the OGC or the Open Geospatial Consortium Simple Features Standard, wherever that makes sense. If you're familiar with working with spatial databases, typically the structure makes a lot of sense. And you can work with these using Spatial SQL, using Python, or using Scala. So it's really open to using any language that makes sense for you to interface with the technology. And then the capabilities, even though this is a notebook-based experience, typically, the capabilities can then be used in other areas of Fabric when they tap into the Synapse-based Spark environment. So for instance, notebooks with GeoAnalytics code can be used in Fabric's Data Factory through their data pipelines workload, which really allows you to create these configurable workflows. These sequential workflows with built-in logic for loops and conditional operations. So you can essentially write almost like little custom geoprocessing tools to be able to run analytics and expose the notebook analysis patterns to people that aren't necessarily notebook specific. They aren't going to be working in the notebook themselves. And something, I just written up some more detail on that. So if you're really interested in thinking about configurable workflows and being able to use scripts as part of these larger workflows, I did write a blog post about that, and that's available through our community site. I can put the link in chat later during the presentation, but we have a GeoAnalytics for Fabric community site with a number of different tips and tricks and resources for getting started. Because since the preview is free right now, you can go in and really just try any of this out using the GeoAnalytics library. And then one last point, just in addition to the Fabric specific workflows, for instance, driving reporting in Power BI and use across OneLake, by leveraging GeoAnalytics in the data science and data engineering environments in Fabric, users can also register a connection to ArcGIS, whether that's enterprise or online. And this allows for read and write between those environments. So you could then do some analysis in Fabric and then write out and export those results as a feature layer for use in maps and applications, such as dashboards, stories, custom web experiences, and even ArcGIS Pro. So with this integration between Esri and Microsoft, there really is a rich connectivity between Fabric and the broader Esri ecosystem to allow individuals across your organization to work in the places that are best for their applications and their analytics flow. So with that, I'm going to pass things over to Edward, and we're going to see some demos.
Cool. Thanks, Sarah. Share my screen now. So now we're going to look into some of the demonstration bits. Right now we're in the Fabric environment, and specifically in one of the workspace, GeoAnalytics. We can see that there's a lot of the environments for the notebooks, the lakehouses, database, and tables that are all visible here and ready to be used. And we're going to start with this specific notebooks. So as Sarah mentioned before, this is a Jupyter notebook sort of environments. That's you could write your script in the cells, and then you can run each of the cell or run it all together. The first thing that we're doing here is to import the GeoAnalytic fabrics. And this is in public previews, and this is just printing out and showing us that modules it's now ready to go, and we can start doing our analysis. Well, before we can do any analysis, we need to bring in the data. So the data that we're going to be doing analysis on here is the crash analysis system data, which is open data from NZTA or Waka Kotahi. So we can quickly view it in the map. And you can see that that's a lot of records, close to 1 million that's been captured over years. Simply as clicking I want to use this and view data source, and grabs the feature service URL from here and just paste it into here. And that's how you can start ingesting a feature service features into your notebook and start doing analysis. Knowing that the features come in NZTM, we can do a bit of data engineering here to transform it into WGS84. So the results as printed out is at the bottoms, so you can see that the coordinates, it's now different. It's showing in longitudes and latitudes after transforming it. The next thing that we're going to do is on the visualizations. We're using the matplotlib to do a static maps plottings to shows the data, the CIS data that we have. We do have documentation and tutorials available online, so feel free to go check those out and learn how to use matplotlib to render a spatially enabled data frame. So we're currently looking at a global scale, and we're looking at the minor injury counts, which is one of the attributes from the data over the world continents. We can obviously restrict or limit the AOI to be just New Zealand because this is New Zealand data, but we can't really see the trends or patterns because it just points a lot of points in maps. This is where we can start using the GeoAnalytic Fabric tools, and specifically we're going to use the find hotspots. Using the find hotspots too, we can set the bin size to be, for this, we're setting it to be 10 kilometers. It could be different unit as well, such as miles. And we're setting the neighborhood to be 200K. You can see that all the records is being pulled in, and this is how many bins has been created. We then want to plot my results using this attribute JBins, which shows the statically significant hotspot or cool spot or the clustering of high or low values. Here we can quickly see the results with a bin of 10 kilometers and such neighborhoods of 200K. Using just the same records, but if we change the variables by the bits, increasing the bin size to 20 and double the distance of such neighborhoods to be 400K, we'll get very different results. And you can also see that this is this was ran probably 20 minutes ago. It was done in 3 seconds. This is another part of the key features of Fabric is you get to use the cloud scales computational resources or computational power without worrying about how to create or maintain the infrastructures, because your admin can just manage all those for you. And this times you can see that the result is slightly different because of the change of bin size and neighborhoods. And I'll just put it side by side so you can see it differently. Just changing the variables, it will change the sensitivities and giving us a very different result, even though it's the same data that we're using here. Once we are done with the analysis, we can share the data back to our lakehouse so that it's accessible through OneLakes, and then you can use it in many different tools and apps. We would just have to specify the output path and then run this one line to write into data formats, and it would then be available in here. You can see that this is my lakehouse, the NZTA CS hotspot. And that also means next time you can just load the data ends into this notebook or any other notebooks or other tools like Power BI. In this specific environment, I've also added a public library, which is the ArcGIS library, that allows us to utilize the ArcGIS API for Python. For those that are familiar with this, it means that you can authenticate to ArcGIS Online or Enterprise Portal. You can get, once you're logged in, just showing that you can get the informations. It means you can take the results or the features, the data frame, spatially enabled data frame here, and create a new feature service so that you can use it in ArcGIS dashboards, map viewers, different applications, or you can use this workflows to update the existing features. Now we'll move on to a different analysis now. Some things that will bring more data together. So this analysis is going to be around SunSmart schools. Last year, we've been supporting the New Zealand Cancer Society to do a project, which is doing SunSmart around parks, which study how critical trees are to providing shades and to provide shade in parks to reduce the risk of getting skin cancers for the kids and for everyone. So bringing the same logics, we want to apply it to school. And to do that, we need to first get the New Zealand facilities or school data and also the tree data together. Let me put it side by side. So using the same concept as the previous notebooks, just we can bring the tree data that are maintained by Wellington City Councils. As this is open data, can load the feature service in. We can also bring in the New Zealand National Facilities datasets from LINS. Then Information New Zealand. And what you can see here is the National Facilities datasets will give us the features that have hospital and school records. And of course, it comes with many other attributes, many other information as well. But in our analysis, we want to purely just focus on school, so we can use the Spark Sessions filter to filters only the school records will be used for the remaining analysis. And now you can see that it's go down from about 2,700 to 2,500 with just school. Before we start the analysis, we want to find the anomalies or do a bit of data cleaning or sanitizations. For example, to remove rows or records like this, which the estimated occupancy is 0. One thing you can use is the data wrangler, and we can set to DF and to school, which is the data frame. The data wrangler show you, give you a nice UI to look at, inspect, and transform the data, and you can see that some of the attributes. And also the estimated occupancy here is 0. It even shows you the charts. So with this, I can just simply do a filters on, we will only want to keep a school that have an estimated occupancies more than 10 or equals to 10. And now, after filtering it, you can see that the records has been removed or not included. Using a interactive maps to shows all the results together. Looking into Wellington, you can see the blue dots, which is the school, and also all the green dots, which is the trees around the school. Clicking on it, we can also find the information of age of trees. Now, this is where we will start doing analysis with using the GeoAnalytics Fabric tools. We are going to use the nearest neighbors to help us to find the trees that are closest to the school. We're trying to defined with a search range of 1 kilometers. And what this tool is going to help us do is to create a line features. It will find the connections of school to trees. So we can visualize all the lines that connect these two features. And here you can see this is the kin tree, closest tree. The tree that are closest to the school that are maintained by Wellington City Councils. Moving a bit to the south, we can also see Hatatai School and where's the closest tree that are maintained by Wellington City Councils. Next thing we can do data enrichment. Here we are using the OSM, OpenStreetMaps data, and specifically the amenities data. We're using it just by going to the tables, and we can do drag and drops, or you can just right click and load data in. And Sujit is going to tell us more about how to use the Snowflake connectors later and to access data from Snowflake platform, from ArcGIS, from Microsoft Fabric. So take a look at the amenities. These layers actually have the cafe, restaurants, the names, and also many other informations about the amenities that we can use. We can also do more data enrichment to bring in authoritative data sets from ArcGIS Living Atlas. In here, we're looking at census data. So we are pulling in the New Zealand socioeconomic deprivations data. And what we are going to do next is to bring this data that provided by StatsNZ and join it with the school data here. So you can see that there's school information in here. And also the deprivation score from the census data. Now all the data is ready to go. This time we'll look into Christchurch. Say this is a hot days and after school, the students want to go to get ice cream or go to get some desserts. They can use this to find out the information for the amenities, or can use it for other purposes to find out what's the school, what is the deprivation score for that areas, and also the estimated occupancies for that facilities. Same thing at the ends, we can share it back to the lake house so that it's accessible through One Lakes, and you can use it for other analysis and in any other apps. So this will be the NZ Enrich facilities, OSM amenities. So these demonstrations highlighted how ArcGIS GeoAnalytics capabilities natively built into Microsoft Fabrics and empowering the spatial insights at scale. While the One Lakes acts like a OneDrive for data and enabling teams across different departments to collaborate seamlessly using a single unified and trusted source of truth. And what most importantly is you can also load in data from other ecosystem, other platform, ArcGIS, and also Snowflake. And now I will pass it on to Sujit to do the demos to tell us more about the Snowflake connectors. Sujit.
Thanks, Edward. So in terms of getting the data from various data sources into Fabric, there are a couple of options. Like you can actually create a shortcut of your existing data platforms and then start using all the Fabric experiences on top of that. But if you take a look at a data source like Snowflake, like if you have an existing investment in Snowflake, you should be able to get data into Fabric in two different ways. You can actually create a shortcut, or sorry, a mirroring functionality from Snowflake. So what that means that the data from Snowflake will get automatically loaded into Fabric, mirrored into Fabric automatically in the Delta Parquet format. So you should be able to use that mirroring functionality to get data from Snowflake into Fabric. And the other option is basically if Snowflake is actually embracing an open source Apache Iceberg format, right? They can write the data directly into the Fabric OneLake. So we have the bidirectional data access between Fabric and Snowflake, where Snowflake can actually create those Iceberg tables and then load that data into the Fabric OneLake. So if you take a look at some of those examples, right? So I do have the OpenStreetMap data in the Snowflake Marketplace, which is the OSM map data for New Zealand. So I basically loaded that data into a database within Snowflake. So you should be able to see the tables like the OSM New Zealand tables in here. And then from there, we can actually mirror this data into Fabric directly. So if you go to the Fabric environment, right, so you can actually create an item called Snowflake mirrored Snowflake. So you can actually go and pick and choose the tables that you or databases that you would like to mirror into Fabric, and that mirroring will be near real time. So you can actually pick and choose the Snowflake connector, provide details like your server names, warehouses, connections, etc. And then you should be able to pick and choose your tables or databases that you would like to mirror into Fabric. So I'll pick an existing connection that you have got with Snowflake. And so once the databases are actually loaded, right, so you should be able to select the database that you would like to mirror into Fabric. So there's an open OSM New Zealand database that we have actually loaded from Snowflake Marketplace. And from here, you should be able to you have two different options. You can either pick and choose the tables that you would like to mirror into Fabric, or you can actually select the whole databases as such. So what will happen here is any new tables that you basically add into the Snowflake database, will automatically get mirrored into Fabric. So once that mirroring is enabled, right, so it should be able to see the status of the whole mirroring functionalities, and then you can see the whole mirroring database to see how it looks like in Fabric. So if you go to this mirrored database, we can see the status that we are actually mirroring your data from Snowflake into Fabric in near real time. So you can see I've turned on the mirroring, the replication from Snowflake. We can see the tables which have been replicated into Fabric. You can see how many rows and when was the last mirroring thing completed. So with that, without even building an ETL process or code, you should be able to mirror the data from Snowflake into Fabric environment. And once the data is actually available in Fabric, right? So as Edward mentioned, you should be able to drag and drop any of those tables and then start using it for all the analytics experiences that Edward has shown in his demo. So this is one way to mirror data from Snowflake into Fabric. And then there is another option, like if we can actually create a iceberg table in Snowflake, and this table can actually store data in an external volume which is sitting in OneLake. So what I've done here is in this example, I create an external volume in Snowflake, which is nothing but the Azure Microsoft Fabric OneLake location, the base URL. So once it's actually created, right, I can actually go and create an iceberg table in Snowflake, which actually stores that data in the external volume, which is the Fabric volume. And then once we have the data in that particular table, right, like the iceberg table, we should then be able to see the same data replicated in Fabric. The data actually gets stored in Fabric. So we can actually see that the DIM customer table that's actually available in Snowflake is automatically available in Fabric in the Delta Parquet format. So Fabric automatically does the conversion of that iceberg format into the Delta Parquet format, and you can then start using this particular table for any of the experiences in Fabric. So those are the two different ways on how we can actually get data from a data source like Snowflake in near real time, and then further enhance it using some of the other experiences that we have in Fabric. Yep, that's at a very high level. So with that, I'll pass it back to Sarah to take us through the roadmap.
Thanks. Scott, do you have the slides to share? Just go to the next slide, please. So just some quick notes on the roadmap. So the GeoAnalytics for Fabric piece is in public preview right now, and that preview will continue until later this fall when we'll go into general availability. So right now, it's free to go in and use, and the capabilities are already documented. We have good developer documentation and an API reference that you can take a look at. Some of the things that we're looking at for future releases and that we're evaluating to bring into the Fabric environment on the GeoAnalytics side, including looking at the feasibility of bringing geocoding and network analysis capabilities, raster analysis capabilities, which we're working on for our broader GeoAnalytics family of products, as well as looking at the feasibility of bringing some of the geo-enrichment capabilities that Esri provides into that Fabric environment. Additionally, as I noted earlier, we do have the maps component as well, which is the workload that we're developing that's in progress, which we're hoping to have available at least for a preview by the end of 2025. And you can go ahead and move to the next slide. I'll pass it back to, I believe, Scott or whoever's going to talk next.
Yeah, thank you. Thank you very much, Sarah. So yeah, thanks again, finally, for that roadmap and view ahead. Thank you all for all your questions you're sending through. Questions are coming through thick and fast. So we'll take a little moment now just to reshare. Actually, let's just share these resources. If you did want to get some of the resources that were mentioned, that Sarah mentioned another one, which was a blog post, and perhaps, Sarah, you can drop a link to that into the chat. There's 3 on screen right now, which will hopefully be useful for you to further your journey. One of those talking more broadly about the Esri and Microsoft partnership. Another, the product information for Sarah's product, which is ArcGIS for Fabric. And then also a little bit of a plug here. We've got our New Zealand Esri user conference happening in September, in the mid-September. We'd love to see you all there. We'll be talking about Fabric and Microsoft and ArcGIS, of course, but the more broader updates in terms of ArcGIS and hearing some amazing customer stories. So if you want to join us there, please scan the code and register, and we hope to see you there. Going back onto the focus for this one, just to remind you, the Q&A, if you want to ask your questions in the side there, if you haven't already, we do have some great questions that have come through already. And to help answer these, we're going to draw on extra resources that I mentioned before. We're also joined by Luke and Jen, also from Microsoft, from Melbourne and Napier. We're lighting up the map here with our presenters and panel today. So let's go through those questions and see if we can allocate them. There's quite a lot of interest around that mirroring that you showed there, Srijith. I wonder, here's one. The mirroring, the question was, does it support mirroring for MS SQL UN database into Fabric? And I suspect that's not a question that you could answer, Sujit. It's probably a Sarah question, I suspect.
Mirroring, I don't know about in Fabric. I think that is a Fabric question about mirroring databases.
I can take that
UN
question.
would be the part. Sorry.
Yep. So in general, right, so we should be able to mirror data from MS SQL, like even if it's an on-premise version, into Fabric. So basically what will happen here is we'll get the full refresh initially and then on the Delta side of things, but you'll actually need to have some access controls on that particular databases. So if that particular database is hosted in your environment and if you got admin rights to configure the mirroring, you should then be able to mirror data from an on-premise SQL server into Fabric.
Okay, cool. Thanks, Regis. I think the complication there might have been around the UN, not United Nations, but utility network, which is an Esri technology. But it sounds like that wouldn't be an issue. And you also mentioned around the ability to do either a delta or a full replace. Yep. So you said that that's good.
Right. So the initial will be the full refresh, and then from then on, it's going to be the delta.
Cool. Thank you, Regis. A very simple one I can answer. People have asked, are these slides or a recording of this webinar going to be available? And the answer is yes, we will be sharing a recording of this webinar very soon on the Eagle Webinar channel on YouTube, so you can share it with folks or maybe rewatch it yourselves. A lot of information being shared, as we say. GeoParquet support, we did cover Parquet, so question here, with GeoParquet support, is it supported to be read write within OneLake?
Yeah, so there are a number of different file formats that are supported. GeoParquet is one of them. You can write as Delta, you can write as GeoParquet, GeoJSON, shape files. You can write back as feature services. So all of those are supported with GeoAnalytics.
Awesome. Thank you, Sarah. A question here about Esri credits. Will there be any costs in terms of Esri credits when executing the geoprocessing tools in the notebook? Probably again a question for yourself, Sarah, and this is beyond the public preview, I assume.
Yeah, so the GeoAnalytics library doesn't use credits, so it's different than some of the ArcGIS online applications. But the way the licensing will work is you'll receive a bundle of what we call core hours, because within Fabric and the Spark environment, it's a scalable computing environment. So you will purchase this lump of core hours, and then it debits from those core hours based on the number of cores in the computing environment that you're using and the length of time that you've been processing.
Awesome. Thank you, Sarah. So there is a different measure of the usage you're making of it there, and it's to do with hours and processing time. Another question around here for Copilot, maybe this is one for yourself, Srijit. Does Copilot in Microsoft Fabric support registering any third-party MCP servers?
Yep, we can do that. So we should be able to create the Fabric data agents and then register a third-party MCP server. So you can actually connect Copilot to various external data sources as well. And then you should be able to run that on top of your data, which is sitting in Fabric.
Excellent. Thank you. Question here around coordinate systems. So can you use the NZTM, which is New Zealand Transverse Mercator coordinate system, in ArcGIS for Fabric? Probably yourself, Sarah.
Yeah, so I am just trying to look that up. But if you look up what's supported by the projection engine within Esri products as a whole, you can bring in the projection engine transformation files.
Perfect. Yeah. So the PE projection engine from Esri fully supports NZTM as well as hundreds of other projections. So
yeah, I just opened the PDF yes. And it was very long.
It's
and
a very
I was trying
long
to scan through.
Yeah,
but yes, if it's in the projection engine, it should be good.
That's perfect. Thank you very much.
You may have to download the projection engine files, which we provide, but they would be able to be tapped into with GeoAnalytics.
Cool. Thank you, Sarah. I think that was all of the questions we had through right now. As I said, thank you again for all of those questions. Thank you for all of our presenters and guests today. We really appreciate you taking the time from around the world to come and join us from the four corners of the globe. Hopefully today's been useful for you. We will share the recording online shortly for you to watch at your leisure. And thank you again to our colleagues at Esri Australia for helping share this webinar information with the Australian GIS community. Really appreciate that. Guys, thank you very much indeed. Looking forward to seeing you maybe at our conference, and if not, online at some point in the future. Thank you all very much. Indeed, have a great rest of your day.